human brain is a remarkable thing. It has enabled us to advance mankind and understand something of the science that underpins our existence, from the smallest atom to whole new worlds. Imagine the possibilities if we were to improve upon human cognitive function. That's one of the objectives of artificial intelligence research. No brain on Earth is yet close to understanding how we might achieve this, despite centuries of trying. It's little wonder that the field of AI, the challenges it presents and the rewards it might deliver, have such a hold over us. It's easy to think of AI as a recent innovation intrinsically linked to the rise of computing. But the origins lie way before that, over 2,000 years ago. Around 350 BC, one of the most preeminent blue sky thinkers was Aristotle. He devised systolic logic, the first formal deductive reasoning system. Aristotle, and the philosophers that followed, were seeking a formal method to represent the way humans reason and think about the world. Fast forward 2,000 years, and in the early 20th century, Bertrand Russell and Alfred Whitehead published Principia Mathematica, a work that laid down the foundations for a formal representation of mathematics. This allowed Alan Turing to show that any form of mathematical reasoning could be processed by a machine in 1942. AI accelerated in pace during the 1950s and 60s. By 1967, Marvin Minsky was predicting that
within a generation, the problem of creating artificial intelligence would substantially be solved.
It seemed that there was no stopping the advancements of AI, but the late Marvin Minsky would probably agree that, by his definition, we're still not there today. So what's gone wrong? Attempts to build systems based on the first-order logic described by those early philosophers failed, due to a lack of computing power, access to large amounts of data, and because they couldn't adequately describe uncertainty and ambiguity. But despite this, the research didn't stop. The development of expert systems started to achieve significant commercial interest in the 1980s. These systems relied heavily on the thinking of those early philosophers and were centered on knowledge. Within these systems, AI started to find applications in fields as diverse as stock trading, oil prospecting, agriculture, and medicine. However, building solutions that made use of this technology was extremely costly. The advances that were made remained accessible only to the largest corporations or constrained to academic research. Furthermore, most of the commercial successes of AI in the 1980s and 90s are systems we would now consider to be mainstream computer science and not AI. Deep Blue, for example, would not be considered to be intelligent, but we would accept that it performed a task that was previously thought to be something specifically human. We now accept that the best chess players are computers, and no longer consider chess to be a task that's uniquely human.
Checkmate.
As a result, chess-playing computers no longer come under one of our definitions of AI. Indeed, John McCarthy, who coined the term AI in 1956, called this phenomena the AI effect. Today, you wouldn't consider your sat-nav to be AI.
As soon as it works, no one calls it AI anymore.
Because of this, it's easy to fall into the trap of thinking about AI in terms of science fiction or as a relic of computing history that never lived up to the hype. So how should we think about AI from here?